Dimension Inc. is a regenerative therapeutics company. We use our proprietary materials and 3D bioplotters to design architecture on the nano, micro, macro level to direct cells towards specific behavior to be able to create a beneficial therapeutic response.
Think of it as applying a blueprint for cells to be able to direct them, how to behave, what kind of function we're looking to direct from them.
One of the interesting things about Dimension Inc. is that we take a material-centric approach to biomaterials design. We understand that in order to treat and restore the function of various tissues and organs of the body, we need to be able to design and create a wide variety of distinct materials. One of the products that Dimension Inc. has developed to address this is 3D printed CM Flex.
CM Flex is a 3D printed bone graft and is the first material that we've developed. It's a material that's made up of hydroxyapatite as well as a polymer. Hydroxyapatite is the main mineral component of bone. It's the first 3D printed regenerative bone product cleared by the FDA.
CM Flex was specifically designed and developed to be a regenerative, restorative biomaterial that is safe to use in patients and works. It restores tissue and organ function.
CM Flex has a specific architecture in macroporosity and microporosity that allows for rapid infiltration of tissue once implanted in the body, and over time it remodels into natural bone. Right now we have a lot of surgeons who love the handability, love the fact that they can cut it to their size that they want, and it's synthetic material that is off the shelf. You can shape it into whatever form you need to fit into the patient very easily. The 3D Bioplotter is a critical tool in our effort to develop and commercialize CM Flex.
It is a very rugged industrial grade system that allows us to do what we need to do, which is transform our biomaterials into 3D printed constructs that ultimately can create these therapeutic products for patients and our surgeons.
We looked at other platforms, and a 3D Bioplotter stood above the rest in its ability to have a software that was user-friendly, as well as its multi-material capabilities.
The body is not just a single material. It's made of multi-materials, so we need to be able to 3D print multi-materials. Dimension Inc.'s materials in combinations with the 3D Bioplotter works really well. We can create those multi-material structures for the body.
So multi-material capabilities is really an important factor in deciding to go with the 3D Bioplotter, because if you think about being able to create devices or products that fulfill organ and tissue function, we need to be able to place different materials and cells within a 3D space.
The bioplotter is more advanced than our current ink formulation right now. It can go all the way down to like 50 micron, 100 micron size tips, and we can go towards very intricate shapes that would go into a certain maxillofacial defect.
One of the great things about the 3D Bioplotter is how intuitive the software system is. It's so easy to use and really allows us to be able to do what we need to do.
We're able to control layer by layer the particular pore structure, pore spacing, fiber diameter, and we're able to do that with ease. On other systems, it might take us days to redesign something. On the Bioplotter software, it only takes us minutes to redesign something and to iterate on it.
The 3D Bioplotter also has high print speeds, which is very important for commercial manufacturing.
It's fast. We can print CM Flex blocks at a rate that is commercially viable. So it's reliable, it's fast, and it gives us the versatility we need not only for research and development, but for manufacturing a product that actually gets into patients.
And now we have 4 bioplotters that are 2 for R&D, 2 for manufacturing. But it really goes to show how pleased we are with the performance of the bioplotter from the first R&D concepts to now through to commercialization.
At Dimension Inc., we're pioneering a whole new class of medicines, a new way of how we treat patients. By being able to combine the unique advantages of our biomaterials platform with the robustness of the 3D Bioplotter, we're able to create these new regenerative products. And we're able to not only restore tissue and organ function, we're able to restore lives.